This is the first mini lecture for section 13.3 of the textbook, which is about statistical inference. In statistics, the group that we wish to study is called the population. So for example, perhaps we want to know, on average, how much television people in the United States watch per week. In that case, the population would be the people of the United States. Remember, population does not refer to a number here. Population refers to a group. In practice, it's usually impossible to obtain data for every member of a population. That's because the population may be too large or too difficult to access. For example, suppose we want to know how much TV people in Eagle Pass watch every week on average. It would take too much time and cost too much money to ask every household that question. By the time you finish the study, you wouldn't really be able to use it because it would cost too much, take too much time to be able to get all that information. Okay, so normally we cannot access the actual population. Instead of getting data for the entire population, we get data on a small subset of the population. The subset is called the sample. If the sample represents the population, then we can draw conclusions about the population based on what's true for the sample. This is called statistical inference. So for example, if we're trying to study Eagle Pass and see how much do people watch there every week, how much TV do people watch there every week, what we would do is get a subset of people in Eagle Pass, maybe 100 people or 1,000 people. Okay, that subset we call a sample. And instead of studying the whole population, then we just study that sample. And if we find, when we look at that sample, that on average people watch, let's say, 6 hours a week, then we can draw the conclusion that in Eagle Pass, people watch about 6 hours a week. Okay, that drawing that conclusion is known as statistical inference. Okay, we haven't studied the entire population. Usually that's impossible. Okay, we have studied a sample, and we infer something about the population just from looking at that sample. Okay, now, in order for our conclusions to be valid, the sample has to represent the population. However, it can be difficult to obtain a sample that truly does that. Okay, so you want your sample of 100 people or 1,000 people to truly represent the population, but in practice, it can be hard to do that. If you have a study that systematically favors certain outcomes, that's called a biased study. And so that's the thing you want to avoid. You want a sample that truly represents the population. And if it doesn't, most likely your study is going to be biased. So for example, suppose we're trying to determine how many times per week the people in the Eagle Pass exercise on average. Maybe they exercise 3 times a week or 2 times a week or what have you. So we're trying to figure out on average how much do people in Eagle Pass exercise. Well, suppose you were to do this by going to a gym and ask the people to fill out a survey. So in conducting this study, the population would be all the people in Eagle Pass, and the sample would be the people at the gym that you happen to have fill out the survey. And now, of course, this study, it's a little bit silly. It'd be very biased because a person who goes to a gym probably exercises more than the average person. So that sample that you're using to study the general population is not actually representing the population. So the goal is to get a sample that truly represents the population. The best approach is to use a random sample, which is a sample that's chosen in such a way that every subset of that size has an equal chance of being chosen. For example, if we had a list of names, like let's say we had every person in Eagle Pass somehow in a big giant list, I could number everyone from 1 to however many people there are, And then I could use a computer to randomly choose, let's say, 100 of those numbers. And then so the corresponding people would be the members of my sample. Okay, typically that's the best way to obtain a sample, is to do it randomly. And again, it's random if everyone in the population has an equal chance of being chosen. Every sample of that size has an equal chance of being chosen. Okay, normally there is not a complete and easily accessible list for the population. Even something simple like the residents of Eagle Pass, you can't easily access a list of those people that's going to be accurate and complete. Well, so if it's impossible to do that, you have to use another approach. For instance, you could call people on the telephone at random, or you can conduct a survey through the mail, or you can go to a shopping mall and ask people questions, or there's any number of ways of doing it. Okay, but it's very difficult to ensure that a study of that sort is not biased. Just about every study that's done has to select the individuals in some manner like this. Think about when you get called on the phone to answer questions for a survey. Well, they're just calling you at random. There's a lot of questions as to whether a sample like that is going to be truly random. Think about, for instance, the fact that not everyone has a telephone, or not everyone has a telephone that's listed. Not everyone, some people might have more than one telephone. And what you have to think about is not whether or not everyone has a chance of being chosen. That's not exactly what you have to think about. What you have to think about is, how will the selection process influence the results of the test? If I'm calling people on the phone, then I'm only going to get people who have listed telephone numbers. Okay, well, what might be true about someone that doesn't have a telephone, or that has their phone number unlisted, that might impact the kinds of things I want to know about? Maybe I'm trying to find out about spending habits, or how many kids they have, or how much debt they have, or how much money they make. Well, your phone situation might be reflective of some other kind of situation. And it's possible that by limiting myself to choosing people that way, I'm going to be affecting the results of the study. So what's important when you're trying to plan a study is to explain why the sample that you're choosing will be representative. And it's not quite enough to say, well, not everyone has a chance of being chosen here. Okay, that may mean that it's not random, but we've seen that most of the time it's impossible to get a truly random sample. What you have to say in order to justify the study is that the way we're selecting people is not going to have anything to do with the kinds of things we're studying. Okay, so here's an example that's on a video. This is on a mental floss video that I linked on YouTube. I linked on Blackboard. It's a YouTube video. So I would encourage you to go watch that. It's just a few minutes long, and then it goes into some kind of interesting and funny things. But there's a couple examples in there of what I think are bad examples of statistical inference. For example, according to the video, 12 million Americans believe that lizard people from outer space secretly rule the world. A public policy polling study asked their sample if they believed in the lizard people hypothesis, and 4% said yes. So think about this. The video says 12 million Americans believe that lizard people from outer space rule the world. They're getting this from a poll. This poll asked people if they believe in the lizard people, and 4% of the people who responded said yes. Well, 4% of 300 million, which is about the population of the United States, is 12 million. So what this video is doing is it's saying, okay, this poll found that 4% of their respondents said that they believe in the lizard people hypothesis. The population of the United States is 300 million. 4% of 300 million is 12 million. Therefore, 12 million Americans believe in lizard people. Now, I've looked this up, and maybe this isn't a fair comparison, but the population of Ohio is less than 12 million. I've met plenty of people from Ohio, even though I haven't traveled around a whole lot, but I've never met one of these lizard people believers. And so that makes me think that there's something wrong with this inference. So that's a question for you to think about. Is this a justified inference? Why or why not? Why do you think it's justified to say that 12 million Americans believe in lizard people? Or on the other hand, why do you think it's not justified?